Okay. We are going to start marking. Question 2. It was given that cos 35 is equal to k. Then the first one asked was cos 215. So I rewrote it as cos 180 plus 35. That would mean the third quadrant where cos is negative. So therefore it's negative cos 35. And therefore it's negative k. Did you get it right? Yes. Sin 55. So my function is wrong and my angle size is wrong. So I tried the co-function, 90 minus 35. That's in the first quadrant. It's positive. Sin becomes cos. The angle becomes 35 and then it's equal to k. Do you get it? Yes. The cos of a negative is the positive cos of the angle, and that's only k. Sin of 665, I just subtracted 360, then it will be 305. I rewrote it as 270 plus 35 because I saw that if I used 360 minus, that would give me 55. It would be the wrong reference angle. So that's why I chose the 270. And then it changes, it's in the fourth quadrant, it's negative, sin changes to cos, and then my angle is 35. And therefore my answer is negative k. Then I got sin to 325. If I chose 360 minus 35, thank you, I see that I have the right angle, but the wrong function. If I chose 270 plus 35, that would mean I'd have the right function, but the wrong angle. And that's how I knew I must now move on to using the diagram. So, you go to what they gave you at the beginning. They gave you cos 35 degrees equal to k. Write it as a ratio, k over 1. 35 is in the first quadrant. There it is. Okay? Doesn't matter if cos is also positive in another quadrant. The angle given is 35. 35 is in the first quadrant. Then you draw your triangle. Remember, draw it down to the 0 degree line, not to 90 degrees. Then you'll be changing everything up. Cos 35 is k over 1. Cos is adjacent over hypotenuse. Then I used Pythagoras. The hypotenuse squared is equal to the right angled side squared plus y squared, where only y squared is the real unknown here. In terms of k means that k is now not considered as an unknown. It's fine if that's part of your answer. So I took the k squared over, it's subtracted, and I square rooted it. That is now the length of the y side there. So now it doesn't matter which one you choose to use. I knew that one is 35, then that would mean that this one is 55. Remember the sum of the angle of the triangles. So if you use that one, it's negative sin 35. Sin is opposite over hypotenuse, so it's negative root 1 minus k squared. If you'd use negative cos 55, cos is adjacent over hypotenuse. Once again, negative root 1 minus k squared. Who got it right? Well done. Grade 11s, I'm telling you, if you go and look at old question papers, you'll see this question a lot. Also, I like to ask it a lot because you get to test many different parts of the trigonometry that we've done. You get to test the reference angle, you get to test the co-angles, you get to test the negative angles, you get to test the greater than 360 angles, and you get this level 4 question where you have to draw the diagram. So it's a lot of things tested in one question. It's a good question. Can I page? Next up was tan 22 equal to t. So tan 202, easy rewrite as 180 plus 22. That's third quadrant, that's positive tan 22. My answer is T. (338), rewrite as 360 minus 22, fourth quadrant, negative tan 22. My answer is negative T. Tan of a negative is the negative tan of the angle, it's negative T. Tan of 518, so I subtract 360, I get 158. Then it's tan 180 minus 22, that gives me, or that puts me in the second quadrant, where tan is negative. It's negative tan 22, and then my answer is negative T. Cos 22, so we're working with tan. There's no way I can get cos to be tan. So I know I must go to the diagram. They gave me tan 22 equal to T. I know that tan 22 is a ratio. No? It's a numerator and a denominator. So it's T over 1. That angle is 22. It's in the first quadrant. The opposite angle there must be 68 because they must add up to 180. Tan is opposite over adjacent. So this Pythagoras was actually even much easier. R squared, which is the radius. Okay, I put that R in there to show you it's the radius. Radius squared is equal to 1 squared plus T squared. And you see now they're all on the same side. I just have to take the square root over, and now I have the length of the radius, which is the hypotenuse in this diagram. So cos is adjacent over hypotenuse, 1 over root 1 plus T squared. Okay, any questions? Do you understand? Can we quickly finish, then you come to me, okay? Alright, you can draw a line, write a heading, special triangles. Okay, so last year you guys learned about the special triangles. Different teachers will teach it to you in a different way. You were with Juffrou Vera, no? Some with Juffrou Vera, others with Van Heerden. Ooh. Oh, both. I thought you said no. Okay, so some teachers, they teach you the special triangles with this circle. Does that look familiar to any one of you? Okay. I don't like that one either. I also teach it with the drawn triangles. Now I'm going to draw them now. But when we were at school way back when, I told you guys this before, our calculators couldn't give the surd form. Okay? So it couldn't give you an answer like root 3 over 2. It would give it as an irrational number. So when we were at school, you had to know the triangles. Once you saw it's this type of question, you had to go and redraw the triangles, and then you read from the triangles. So that is still simple enough. If you prefer to do it like that, then it's fine. Okay, so you can either use the triangles or you can learn that circle, or, and this is the easiest but the trickiest way, is just to remember which angles are special. Okay, so it's going to be 0 degrees, 45, 30, 60, 90. It's actually all of the points that has critical values, where there's a turning point or where there's an intersection with the x-axis. But if you were to use the triangles, I want you to also draw them so you know where the values are coming from. So the first triangle is the 30 and 60 degree triangle. The second one is 45 and 45. And then the last one, that's one that's a little bit difficult to understand. It's the 90 and 0 degree triangle. Okay, so quickly draw them and then I will talk to you about it. Okay, the first triangle is easy to understand. Remember, to do trigonometry, we need to have a 90-degree angle. Okay, so the other two, it's 30 and 60, making up the remaining 90 degrees. Then 90 degrees, the other two, 45 and 45. So then I have one 90 degree here. Now I want you to look at these two pens. The 30 and the 60 is like open like this, then it's just joined here at the bottom. Okay. Then the 45, same type of story. But when I have, imagine these two lines are these two pens are the two sides of a triangle. When I bring them closer to each other, can you see that angle there at the top is becoming smaller? And then the length of this bottom line, the distance between it here, is getting smaller as well. Okay. That's what's happening. But what's actually getting bigger are these two angles, the bottom angles. They're getting bigger and bigger and bigger when I move them closer to each other. And if I were to put them right on top of each other, it would mean that that angle at the top is now 0 degrees. There is no space between them. And that would mean that the bottom the bottom angles will both be 90 degrees. So it's not like a triangle like we can imagine in our heads. It's actually just two lines on top of each other. 0 degrees, 90 degrees, 90 degrees. Do you understand? So you can imagine this because it doesn't really exist as a triangle, as the shape. But the angles do exist. Okay. Alright, so then you'd know the length of the sides. With this one, it's 1, 2, root 3. It's 1 and 1 and root 2. And this one is 1 and 1 and 0. Okay. So if you were to use this thing, you would say the sin of 30 is opposite over hypotenuse. It's 1 over 2. Aha. And you can test this on your calculator as well. The cos of 45, let's see, it's adjacent over hypotenuse. Now just quickly, anyone who has their calculator closed, just quickly check for me, what does it say on your calculator if you type in cos 45? Root 2 over 2. Do you hear that's different from what I have here? Is there anyone who can tell me why does the calculator say root 2 over 2? And I say it's 1 over root 2. Homotso. Okay, if you time this with root 2 over 2, it's going to give you root 2 over root 2. It's going to give you root 2 over 2. And what we did there is, if you remember back to the first term, the rationalization of the denominator. Do you remember? Ne? So this is an irrational number, so we rationalize the denominator. Okay. Your calculator does that by itself. Okay, tan of 45, tan is opposite over adjacent, 1 over 1, which is just 1. The cos of 30 degrees, adjacent over hypotenuse, root 3 over 2. And then the tan of 30 degrees is opposite over adjacent. It's 1 over root 3. What do you think this answer would have been on the calculator? Root 3 over 3. Okay, now I just quickly want to show you how we would read the answers on this triangle that doesn't exist. Okay? Just quickly in your mind's eye, can you remember what the sin graph looks like? It starts at 0, no? What's the value at 90? 1. Cos, what's the value at 90? 0. Tan, what's the value at 90? Mass error, it's undefined. No, undefined because it's an asymptote. Okay. Now look at this. This is now your angle 90. Doesn't matter which one you choose now. I'm choosing that one now. So sin would be opposite over hypotenuse. 1 over 1, which is 1. You guys just said it would be 1, ne? Cos is adjacent over hypotenuse. It's 0 over 1 and 0 over 1 is 0. Tan of 90 degrees would be the opposite, which is 1, over the adjacent, which is 0. And 1 divided by 0 is undefined. But, grade 11s, all you need to do is know and recognize those special angles, and then you can type it on your calculator. So you don't have to use these 3 triangles. It's perfectly fine if you do, but you can cheat on your calculator. The reason why I said it's the easiest but the trickiest way is because you must know where you will be pushing it, pushing your limits, cheating on your calculator. Okay. You are only allowed, when you come across a sin 30, to calculate the value of sin 30 and put that in. Do you understand? Okay. You can write example 1. Okay. Everything we're going to do is the same that we've done up to now. Okay? If I have 150, I see that it's not a reference angle, ne? How can I rewrite it? 180 minus 30. Then I would say it's in the second quadrant. Ne? What is cos in the second quadrant? Negative. But the square makes it positive again, ne? Okay, so it's positive cos squared 30 degrees. And this is now the new step. Yesterday or last week we would have stopped there. But because this is a special angle that you recognize, you will now take your calculator. And you type in there, not cos squared 30, cos 30. That's what you would have read from the triangle. Do you agree with me? Okay. So what is cos 30? Root 3 over 2. And then you substitute that in and you give it the square. And then you calculate it. If you can't calculate that in your head, then it's fine. You can do it on your calculator again. No? But you cannot say cos squared 30 and immediately give the answer 3 over 4. You're going to have to show this. So it's not that we are pressing for a specific method or punishing you to show things. You understand that this is very easy to just type on your calculator and get the correct answer without having any knowledge of trigonometry. Do you agree with me? So you understand why you have to show the steps. So just writing the answer would result in a 0 marks. Okay. Example 2. Tan negative 300 sin 600. Okay. We do this normally. The tan of a negative is negative tan of the angle. Instead of 300, I'm going to write 360 minus 60. Do you understand what I did thus far? 600 is too big. I throw away 360. That's 240. Okay? So I say the sin of 180 plus 60. That gives me 240. Do you understand why I said don't use cofunctions just for the fun of it? Because there are so many things happening in one sum. If you can just make one, give it one step less, then it will be better. Okay. Which quadrant is this? Fourth. What is tan in the fourth? So what's the answer going to be? Positive. Can you all see that? Okay. So it's positive tan 60. And this one is in the third quadrant. Therefore, it's times negative sin 60. So last week, we would stop here. There wouldn't be anything that we can do further. But now we recognize that 60 is special. So you take out your calculator. You don't type in tan 60 times sin 60. You type in tan 60. And then you get root 3. Then you type in sin 60. Then you write it negative root 3 over 2. Now to do the multiplication, I put in the multiplication sign. And now listen to me. I'm going to say it again. If you can't do this multiplication sum, you can do it on the calculator. Because whether I typed that or whether I did it in my head, would you know? No, you don't know if I did this in my head or I did it on a calculator. So it is safe that you can now use the calculator to do the sum. Okay? Especially if there's a lot of things happening in one. Because you'll see with the homework, there can be more than just these two terms. Okay? But don't use the calculator from there and write the answer. You understand why? Okay. Are you done? Alright, now look at what can also happen. Example 3. Okay. You all know the cos of a negative is? Positive cos of the angle. Now, let's say I am in my next step now. Then I have cos 200. No. What would the reference angle be that I get if I use 180 plus or whatever? What would the small angle be? 180 plus what is 200? 20. Is that special? No. If I use 270 minus, the reference angle would be what? 70. Is that special? No. Do you see I have a problem? These angles aren't special. Okay? But what we used to do is we get them as a reference angle. So that's what we're still going to do. So we say the cos of a negative is the positive cos, and I write 180 plus 20. At the bottom, the sin of 290. Now I see if I say 360 minus 70, that also is not special. Now in the Afrikaans class, they couldn't answer the question. Let's see if you guys can. What do you notice about these two reference angles? Gomot, was your hand up? Tell me. Co-functions. You remember we said with co-functions, the reference angles, they add up to they add up to 90. So 80's co-function angle will be 10, 70, 20, 60, 30, 40, 50, 50, 40, and so on. Do you remember that? Okay. So I immediately saw that, so I stopped myself there. I'd rather get them to be the same. Because when the angle is the same, then I can work with them. So I chose to change the denominator. I said instead of 360 minus 70, I'm rather going to use 270 plus 20. Do you see both of those brackets also give me 290? But this one would result in a sin and a 70 angle. This one would result in a cos and a 20 angle. And then I would have the same at the top and the bottom. Do you see that? So at the top, that's the third quadrant. It's negative cos 20. This is the fourth quadrant. It's negative, change to cos 20. And then my answer is 1. So although they weren't special, they cancelled out. Now the next example. They've thrown all of this together. Now I'm going to give you a chance to do this example by yourself. If you are afraid, you use your pencil. That's fine. I will give the first step in a moment. Just quickly look here. If you have cos of 180, you would say, for example, cos 180 minus 0. Then your special angle will be 0. Someone in the Afrikaans class asked if they can use 90 plus 90, because 90 is also special, ne? That's fine, but then you're working with co. You're playing. Ne? Remember, I also showed you guys on the graph, ne? Whether it's cos negative or 180 plus or minus, it gives the same result. Okay. Can I give you the first step? So at the numerator, I said 180 plus 0. Minus 0 would have been fine as well. 180 plus 45. And then I saw that if I used co with this cos, it would be 10. So this thing is not special no matter what I do. Okay? When I went down to the bottom, I saw that the one I would choose, 180 minus, would give me a reference angle of 10. Did you notice that? 10 and 80. 10 and 80. I can get them to look the same. So I chose, instead of 180 minus 10, I chose 90 plus 80. You remember I told you guys there would be a time where we would choose to use the co-function. It's here, because the ones that are not special, we want them to look the same so that they can cancel out. Maar as dit nou, ek het nou op die groepie opgeselsel. Net sien as dit nou baie reën 2 uur. Ek weet nie wat om te doen met die reën, mami. Nou, ga jy nie terug is nie. Ek gaan terug nie. Betyd? Vanaf? Okay. Dit is nou 2 uur. Hoe gaan jy 2 uur terug wees? It's 1:30. How are you going to be back at 2? Maar jy hoef eers 3 uur hier te wees. Okay. Can I go on to the next step? Right. So 180 plus, whether I said plus or minus, it would both be negative, no? So it's negative cos 0. Then this one is third quadrant times negative sin 45. Then it was cos 80. At the bottom, second quadrant, sin changes to cos, is positive, and then 80. And do you see how they look the same now? That one is in the second quadrant, so it's times negative tan 45. And now you cancel those two cos 80s, you use your calculator. You type cos 0. Then it's negative 1. Then you type sin 45. It gives you root 2 over 2. You put in that negative. Okay? Then you type tan 45. It's 1. You put in that negative. And then you can either do it on your calculator, or you can calculate it yourself and you get an answer of negative root 2 over 2. And then that's your homework. Must I write exercise, or do you understand oefening? Are you okay? Okay. Exercise 6, page 153. Number 1, A, B, G, H, I, J, K, and L. Okay. Very important. These questions that you are going to do this afternoon, they are also exam questions. Remember, I'm not going to ask you the sums like the way we started it. Now we're only doing reference. Now we're only doing co. Now we're only doing negative. It's going to be like this, everything thrown together. Okay. And there's definitely one like this in every question paper. 5 to 6 marks.